Hi guys, here is your video on 3.2 properties of division. So this video focuses on dividing polynomials using long division and synthetic division, as well as looking at the remainder and factor theorems. So the first thing we're looking at is long division for polynomials. So we want to find the quotient and the remainder when f of x is divided by p of x. So I'm going to take x to the fourth minus 16 and divide it by x squared plus 3x plus 1. So what I'm dividing by, so that p of x is going to be, I'm going to write this on my left side. So I have x squared plus 3x plus 1, and I'm dividing into x to the fourth minus 16. So this is like the long division bar that you did back in elementary school, except we're working with polynomials instead of numbers. So with division, you have to make sure you have every single term of the polynomial. So since my polynomial starts with an x to the fourth, that means I need an x cubed, an x squared, x, and a number. But of course I'm missing all of those middle terms. So I'm going to go ahead and put in zeros as placeholders. So 0x cubed plus 0x squared plus 0x, and then finally minus 16. Okay, so now starts the process of long division. You're focusing on that first term, the x squared, and you're thinking to yourself, what times x squared gives you this term right here, x to the fourth? Well, x squared times x squared gives you x to the fourth, so I'm going to go ahead and put x squared on top of my x squared term. Now, whatever you put up here, you're going to take that and multiply it by your p of x. So I'm going to take my p of x multiplied by x squared. So x squared times x squared is x to the fourth. X squared times 3x is 3x cubed. And x squared times 1 is just x squared. Now with normal long division you would subtract, so you're going to do the same thing, but for polynomials make sure you subtract every term. So I'm going to draw my line and change my signs. And then combine your terms. So x to the fourths are going to cancel, which they should, because your first term should cancel. We can combine the x cubes, so that gives you negative 3x cubed. And then combine your x squares, so minus x squared. And then I can go ahead and bring down the next term, which is the 0x. Okay, so now the process repeats itself. So I'm trying to find what times x squared gives you negative 3x cubed, and that's negative 3x, and I'm going to put that on top of my x term, so minus 3x. I'm going to multiply my p of x by negative 3x, so negative 3x times x squared is negative 3x cubed, negative 3x times 3x is negative 9x squared, negative 3x times 1 is negative 3x. Again, since you are subtracting, I'm going to draw my line and change my signs. And then I can combine my like terms. So x cubes cancel, negative x squared plus 9x squared is 8x squared plus 3x. And then I can bring down my last term, minus 16. Process repeats itself, so what times x squared gives you 8x squared? That's 8. So I'm going to go ahead and put plus 8 up there. I'm going to multiply 8 by my p of x. So 8 times x squared is 8x squared. 8 times 3x is 24x. And 8 times 1 is 8. Gonna draw my line, change my signs. X squares cancel. 3x minus 24x is negative 21x. Negative 16 minus 8 is negative 24. Okay, so your final answer, you're going to write out the quotient and the remainder. So your quotient is what is sitting on top of your division bar. So that's the x squared minus 3x plus 8. And your remainder is the leftover at the bottom, so the negative 21x minus 24. And there is your final solution. So we're going to write the quotient and the remainder separately. We're not going to connect them together. We're just going to go ahead and keep them separated. Alright, let's go ahead and do the next one. So my p of x is x cubed minus 2x plus 7. So I'm going to write my p of x on the side, x cubed. Now if you notice, your p of x is missing the x squared. So I'm going to put plus 0 x squared as a placeholder, minus 2x plus 7. And I am dividing into the f of x, so let's go ahead and list out those terms. So that's 3x to the 5th, missing the x to the 4th, so that's plus 0x to the 4th. I have the x cubed, so minus 4x cubed, missing the x squared, so plus 0x squared. I have the x, and I have the constants. Okay, let's go ahead and work through the long division. I'm looking at that x cubed. You think to yourself, what times x cubed gives you 3x to the 5th? That's 3x squared. So I'm going to go ahead and put 3x squared above my x squared term. I'm going to multiply 3x squared by the p of x. So 3x squared times x cubed is 3x to the 5th. 3x squared times 0x squared is 0, but I'm going to go ahead and multiply my x's together. So you get 0x to the 4th. That way I know that it is an x to the 4th. 3x squared times negative 2x is negative 6x cubed. And 3x squared times 7 is 21x squared. Alright, I'm going to draw my line, change my signs of all of the terms, and then I can combine. Your x to the 5ths cancel, your x to the 4ths also cancel. So I'm going to go ahead and pick up with my x cubes. So that is 2x cubed. I can combine my x squares, so minus 21x squared, and then I can bring down the next term, so plus x. Now you're thinking, what times x cubed gives you 2x cubed? That's 2. Now since 2 is a constant, I'm just going to go ahead and put that above the constant term. And then multiply, so 2 times x cubed is 2x cubed. 2 times 0x squared is 0x squared. 2 times negative 2x is negative 4x. And 2 times 7 is 14. Now if you notice above the 14 we did not actually have a term there, so I'm going to go ahead and bring down the 5x as well, or the 5 as well. That way we have coinciding terms on top of each other. Now the reason why you end up bringing 2 terms down for this particular scenario is because if you look at this, those x to the 4ths ended up canceling as well. So we actually skip a line with the long division because we don't have this piece right there, so the piece above the x. So we didn't actually have to multiply by an x term since our x to the 4ths canceled. So let's draw our line, change the signs. Your x cubes cancel. That leaves you with negative 21x squared plus 5x minus 9. So we can write our final answer. Sorry about that, guys. My son is throwing his toys all over the place. So my quotient is 3x squared plus 2. And my remainder is negative 21x squared plus 5x plus 9. And that is our final answer. Alright, so now we're going to start to look at zeros, factors, and roots. So there's the next slide that has a lot of important information on it. So zeros, factors, roots, and x-intercepts are all related. If f of x is a polynomial function with c as a 0, then x minus c is a factor. So it's important to know that it's a factor in terms of division, because if you were to divide a polynomial that has a certain factor, then the division would go unevenly, so you wouldn't have any sort of remainder. The other thing, if c is a 0, then c is a solution or a root. to the equation f of x equals 0. So if I took the polynomial and set it equal to 0 and solved, c would be a solution to that. If c is a real number, then c0 is an x-intercept. It has to be a real number because we can only graph real numbers, but we do have zeros that are imaginary, like for example 2i, but you wouldn't be able to graph that, which is why it says if c is a real number right here. So factors, zeros, roots, and x-intercepts are all connected. And then we're going to look at that with the factor theorem, which is next. So the factor theorem states that a polynomial f of x has a factor x minus c if and only if f of c equals 0. So that connects a couple of the pieces from the last slide together. So if it's a factor, then that means if I take that number and plug it in, it should equal 0. So it should be a solution to the equation f of x equals 0. So this example says to use the factor theorem to show that x minus c is a factor of f of x. So with this one, I flat out say that c is 2, but sometimes instead of saying that c is 2, I might just list the factor there. So if c is 2, then that means the factor is x minus 2. So you might see it both ways, with the c equals 2, or I might just say the factor being x minus 2. Now to show that x minus 2 is a factor, we need to evaluate f of 2 and see if that equals 0, because the factor would go in evenly, and that c would result in a 0 when you plug it in. So let's go ahead and take 2 and plug it in for x. So I have 2 to the 4th minus 3 times 2 cubed minus 2 times 2 squared plus 5 times 2 plus 6. You can take that entire thing and plug it into the calculator, and when you do that, calculator is going to spit out a 0. So that right there shows that x minus 2 is a factor. So since it equals 0, we have just proved that it is a factor, so you're done. Check mark, smiley face, move on to the next problem. Okay, synthetic division. So synthetic division is another way to divide polynomials. It's a shorthand version of long division. Synthetic division does not work with every type of division problem though. Synthetic division only works if you're dividing by a linear function. So for example, x plus 3 is a linear function. X plus 7 is a linear function. 2x minus 5 is a linear function. But if I ever throw an x squared at you, you're kind of forced to use long division because you can't use synthetic division for that. Synthetic division, you start by putting your box in the corner. What goes in that box is going to be the opposite of that value right there, so it's essentially your c. So since my factor is x plus 3, or not my factor, since I'm dividing by x plus 3, I'm going to go ahead and put negative 3 in that box. Synthetic division only works with the coefficients. So we're going to list out the coefficients. So that's 2x to the 4th, 5x cubed. Since I'm missing the x squared, I'm going to go ahead and put a 0 in as a placeholder, minus 2x, and then minus 8. I'm going to leave some space and put another box underneath the 8. This box over here is the remainder box, so whatever you get in that box is your remainder. For synthetic division, your first term goes straight down, so 2. You're going to take 2 and multiply it by what's in the box. So 2 times negative 3 is negative 6, and then we're going to combine straight down, so 5 and negative 6 gives you negative 1. Negative 1 times negative 3 is positive 3. 0 plus 3 is 3. 3 times negative 3 is negative 9. That gives you negative 11. Negative 11 times negative 3 is 33. And then 33 minus 8 is 25. Alright, so what do these numbers mean? This row over here represents the coefficients to your quotients. So since the original polynomial started with the x to the 4th, that means your quotient starts with an x cubed. So your quotient is 2x cubed minus 1x squared plus 3x minus 11. So I got these numbers right here to create my quotient, just putting the variables in the right spot. And then your remainder is that number that's in the remainder box, which is 25. So synthetic division goes by a lot faster than long division. But again, synthetic division doesn't work with everything. Alright, remainder theorem. So the remainder theorem says that if a polynomial f of x is divided by x minus c, then the remainder is the same thing as f of c. So I have my original function and my c is 4, so that means I am dividing by x minus 4. Now the remainder theorem is another way to evaluate functions. So we know how to find f of c. You could just take 4 and plug it in. But let's say we wanted to do that using division. So I'm going to go ahead and use the synthetic division with the remainder theorem. So since I am dividing by x minus 4, I'm going to go ahead and put positive 4 in that box. So if I give you the c is what goes in the box. If I give you the factor, or what a linear function, and you're dividing by that, you always use the opposite of that number. So I have my 4. I'm going to go ahead and list out my polynomial coefficients. So 3x to the 5th, missing an x to the 4th, so that's a 0, minus 38x cubed, 5x squared, 0x, and minus 1. Leave some space, draw my line, going to put my remainder box. So synthetic division, first term goes straight down. 3 times 4 is 12. Combine. 12 times 4 is 48. Combine. 10 times 4 is 40. Combine. 45 times 4 is 180. Combine. 180 times 4 is 720, and then combine. So that gives you 719. So we're using the remainder theorem, which means that the 719 is equivalent to f of 4. So f of 4 equals 719. Now I can double check that by taking that and plugging it in for x. So 3 times 4 to the 5th minus 38 times 4 to the 3rd plus 5 times 4 squared minus 1. And when I take that and plug it in, it gives me 719. So again, the remainder theorem is just another way to evaluate functions. Alright, so that covers all the material for section 3.2.